Well, we have an ellipse with vertices and a covertex. There's two covertices. We aren't given both of them. But to find the center of the ellipse, that's an important part. All we need are two things like this, vertices. The midpoint of our vertices is going to be the center of the ellipse. So if I take these two numbers, the 1 and the -5, add them together. What's 1 plus a -5? Well, it's a -4. If I find the average of that, divide that by 2, I get a -2. Okay? So that's the x value of my ellipse. Now you can kind of say, well, I can add those up and divide them by 2 and you'll end up with the same thing, but if they're consistent like that, if they're the same, then the center has to be in the same spot as well. We'll take a look at how that looks. 1, 1 is here, 1, -5 is down here. And then, who am I? Let's just keep that. Let's keep that. 1, I did 1 and 1. But -5 and 1 would be back here and up, okay? That'll learn you if you're using pen. Use pencil. Sorry about that mistake. Back 2, up 1. There I am right in the middle, and you can kind of see. They're all 1s on the y, so you can see that it's right in the middle. Now we have a covertex at -2, 0. That's here. So you can kind of glean from that where the other covertex is. It's got to be on the other side of the center at the same distance away. That distance is important because that distance is your b value. A is the greater value, and that is 3 in both directions here. So A is 3. B is the distance up and down, and B is just equal to 1, plus or minus 1. So the coordinates of the ellipse's other covertex is this guy up here. I went back 2, but I went up 2. So -2, 2. And the equation of the ellipse, which I'll remind you, is x minus h quantity squared over something, plus y minus k squared over something else equals 1. The reason I paused on the something is a could either be a squared here or a squared here, depending on which way it opens. This one here opens back and forth. It's a horizontal ellipse, so the a squared should be attached to the x, and the b squared should be attached to the y. So if our center is the h and the k, I've got an x plus 2 squared over a squared, and if a is 3, I've got a 9 underneath, plus y minus 1 from the center squared over 1 squared, which is just 1, also equals 1. There's your ellipse.